Have you ever really thought about what's left when you take everything out of a box? I mean, absolutely everything. Every single atom, every particle, every photon. You're left with a perfect vacuum, right? Pure, empty nothingness. But what if that nothing could push and pull? What if there's a kind of phantom force hiding in the void? Today, we're going to explore a mystery that challenges the very idea of what empty space really is. So let's dive right into this phantom force. It all kicks off with a really bizarre but very real experiment known as the Casimir Effect. And look, this thing has been confirmed over and over again. It all starts with a pretty simple question. Just try to picture it. You've got two perfectly smooth, uncharged mirrors floating in a total void. There's no air, no particles, no radiation. I mean, logically, nothing should happen, right? They should just hang out there. Wrong. What actually happens is the mirrors get pushed together. And this isn't some theoretical quirk. It's a real, measurable force. We're talking experimentally verified with up to 1% precision. So what on earth is doing the pushing? Well, the standard explanation from quantum field theory, or QFT, is that the vacuum is actually this bubbling sea of virtual particles. The idea is that the space between the mirrors restricts which of these particles can pop into existence. But outside, it's a free-for-all, so you get an imbalance, more stuff on the outside pushing in. But this explanation comes with a massive problem. To make the math work, you have to start by assuming there's an infinite amount of energy everywhere in the universe. Now, the way physicists deal with that infinity is where things get really interesting. It kind of reveals what some people might call a dirty little secret of theoretical physics. They use a mathematical shortcut to explain a very real physical force. And hey, don't just take my word for it. You've got prominent physicists like R.L. Jaffe from MIT who argue that these virtual particles are just artifacts of perturbation theory, which is really just a fancy way of saying they're a product of the calculation method. He basically sees them as a kind of mathematical bookkeeping, not actual proof that the vacuum is fizzing with energy. The tool they use to tame these infinities is called regularization. You can think of it as a set of rules for subtracting infinity from infinity to somehow get a sensible finite number. It's a super important part of a physicist's toolkit, but man, it leads to some truly mind-bending results. For instance, one of the most common methods uses something called the Riemann Zeta Function, and it famously assigns the value of -1/12 to the sum of all positive integers. Yes, you are seeing that correctly. An infinite sum of positive numbers somehow equals a negative fraction. Now, this trick does give the right answer for the Casimir effect, but you have to admit, it feels less like physics and a lot more like mathematical magic. And this gets us to the absolute heart of the matter. Are we just using a clever math trick to get the right answer, or are we actually describing what is physically happening in the vacuum? Is there a better way to think about all this? Well, this brings us to an alternative theory called dynamic vacuum field theory, or DVFT for short, and it proposes a totally different picture. It suggests that we need to completely rethink the vacuum itself. What if it's not empty at all? What if it's actually a physical substance? Okay, so here's the core difference. QFT sees the vacuum as fundamentally empty space, just defined by these abstract mathematical fields. DVFT, on the other hand, says no, the vacuum is a real physical medium, kind of like a superfluid that fills all of space, with actual tangible properties we can describe. And the DVFT explanation is it's wonderfully intuitive, it's brilliant. First, you've got this physical medium. The mirrors, they act like boundaries that restrict how this medium can behave between them. This creates a genuine pressure difference. Think about the pressure difference that creates lift on an airplane wing. And the result? A real mechanical force pushing those plates together. No infinities, no mathematical sleight of hand. All right, so let's put these two theories head to head. How does DVFT's really intuitive mechanical approach stack up against the abstract, infinity-filled math of standard QFT? This table really just lays it all out. QFT explains the force with these abstract virtual particles, using what you might call unreal math, like zeta regularization to handle those infinities. But DVFT sees it as a simple mechanical pressure difference in a physical medium, and it uses real math based on a physical cutoff, which is just the common sense idea that a real-world system, like a mirror, can't actually handle infinite energy. It has a natural limit. The physical intuition is just so much clearer because it feels grounded in reality, not just a mathematical procedure. And get this, here's a really fascinating piece of history.
When Hendrik Casimir himself first calculated the effect way back in 1948, he didn't use the zeta function. He used a physical cutoff. He basically argued that a real metal mirror can't possibly reflect waves of infinite energy. So his original logic was actually much, much closer to the physical mechanical reasoning of DVFT, grounding the whole thing in the real world. Look, this isn't just some philosophical debate about math. There are ways we can actually test which of these ideas is closer to reality. And the ultimate test involves something even weirder than that static force we started with, literally creating light out of a pure vacuum. This is called the dynamic Casimir effect, or DCE. The theory predicts that if you can move one of the mirrors, or just change its properties, fast enough, you can literally shake the vacuum and cause real particles, actual photons of light, to spring into existence. And what's incredible is this has been experimentally confirmed. I mean, stop and think about what that means for a second. By just shaking a mirror in the dark, we can create light from nothing. This makes the DCE the ultimate laboratory. It gives us a handle to literally poke and prod the vacuum to see what it's actually made of. And this is where we can design experiments to tell QFT and DVFT apart. So here are 3 concrete, testable predictions where the two theories totally diverge. First, DVFT suggests the vacuum medium has its own natural frequency. So if you shake the mirror at that exact frequency, you should see a resonance, a huge spike in photon creation. QFT? It predicts nothing of the sort. Second, DVFT also says that shaking the vacuum to create these photons should also create gravitational ripples. QFT says, nope, shouldn't happen. And finally, DVFT's stiff vacuum model implies it gets harder to create particles at really high energies, whereas QFT predicts the opposite. These aren't just thought experiments. These are real experiments we can actually run to get a definitive answer. So we're left with this really profound question. I mean, the nature of the vacuum underpins everything we know about cosmology, particle physics, gravity, the whole shebang. By probing this tiny force between two mirrors, we might just discover that the nothing that fills all of space is actually the most important something in the entire universe. And the answer could be waiting right there in a lab, ready to be uncovered.